All right, so now we're going to do some practice problems, just talking about going over some of the things we've learned at the beginning of the notes. So the very first problem you see is we see a right angle here, and it is vertical, these two angles. So we know that together, those two angles would also together create a right angle, which is 90 degrees. From that, we can do some basic algebra of knowing that x plus 2x would sum to 90, meaning 3x is 90, going through and dividing by 3, giving me that x is 30. And so if x is 30, this angle is 30 degrees. 2 times 30 here above would make this angle 60 degrees, and those two angles do excuse me, add to 90 degrees. On the next problem, we're looking for this angle that is marked with x. And so what we're going to do, and I apologize, I am choked up, but we're going to use some vertical angles, some supplementary angles, the fact that a triangle adds up to 180 degrees to help us here. So if this is 42 degrees, we know the angle vertical to that is 42 degrees. And we don't need to find the other angle up in that top piece, but I want you to realize that you can do 180 minus 42 to also find that this angle is 138 degrees, and then the angle vertical to that is 138. And you'll see that every line there would sum up to 180 degrees, and then full circle, we're at 360 degrees. We also have a supplementary pair, including one of the angles being 129. So if this is 129, then we know that this angle is 51, because together they are supplementary. They make a straight line. We would know that this angle is 51, and the angle vertical to the 129 would also be 129. We can use the fact that a triangle sums to 180 to zoom in right here on this triangle and take 51 and 42 and add those together. Subtract that from 180. So that's going to be 180 minus 51 and minus 42, which is 180 minus 93, telling us that this angle is 87. And now the three angles of this triangle add up to 180. This is vertical 87, so it would also be 87, but we could also, if we needed to, take, we have these linear pairs here, these supplementary pairs, and find that these angles here are 93, making each line here sum to 180. But what the question asked for, and I found much more than that, was x, and x is equal to 87 degrees. The next question, I want the sum of the interior angles of a decagon. And if you recall, a decagon has 10 sides. Now, if you need to go back up in your notes, and remember I suggested that you write these formulas on your note card for your exam. If I want the sum of the interior angles of any polygon, we have a formula for that, and we've already talked about that in the previous video. The formula is to find how many degrees all 10 angles in a decagon add up to. We would do n minus 2 times 180. So that's going to be 10 minus 2 times 180, which is 8 times 180. And so if we do 8 times 180, we get 1,440 degrees is what all 10 angles in a decagon would add up to. Now on the next question, I want one angle, and now it's specified in this question that we have a regular decagon. That was not specified in number 3. Number 3, just for any decagon, what do all 10 angles add up to? But if I'm saying now that it's a regular decagon, we know that all 10 angles are the same and all 10 sides are the same. So that's why you do n minus 2 times 180 and divide by n, because that's going to find one angle when all the angles are the same. So then we'll do 10 minus 2 times 180, and then divide that by 10 angles because all 10 angles are the same. We've already worked out the top in the previous problem to know that there's 1,440 degrees in a decagon. If we divide that by 10, that's going to tell us if it's specifically a regular decagon, all 10 angles are the same. Each one of those 10 angles is 144 degrees. All right, the next question. Find the number of sides of a regular polygon if each interior angle has a measure of 162. So kind of just a visual on that. I don't know how many sides this has, but I know that in whatever polygon this is, it would continue on, that each interior angle is 162. So 162, etc. And I want to know, okay, how many sides does this polygon have if it's regular, meaning all it's equilateral and equiangular, and I have one angle 162 degrees. Each angle is 162 degrees. Now the way that we find this is we take the number of sides minus 2 times 180 divided by n. That's the formula to find one angle of a regular polygon. So that's what was done, and when that formula was done, the answer that was got was 162 degrees. So now we just need to do some algebra and work backwards and figure out, okay, well, how many sides would the polygon have if each angle is 162 degrees? So we're going to go through and multiply by n, and then I'm going to distribute the 180 up top. So that's going to give me 180n minus 360, because that's 180 times 2, and that's going to be equal to 162n after I multiplied through by n. I now want to put all of my n's on the same side, so I'm going to subtract 180n. I have negative 360 equals, and then I'll do 162 minus 180, giving me negative 18n. Divide by negative 18, divide by negative 18. Recall a negative divided by a negative is a positive. So when I take negative 360 and divide it by negative 18, I get that the number of sides for this particular polygon is 20. So a 20gon, if it was regular, would yield each interior angle of 162 degrees. All right, the next question, find the sum of the exterior angles of a 32gon. Find the measure of excuse me, I might have said interior, I don't know. I apologize if I did. Find the sum of the exterior angles of a 32gon. Find the measure of one exterior angle of a 32gon. And I showed you guys the visual. Remember, exterior angles are created when we extend a side of a polygon, and it creates an exterior angle with that extended side and an adjacent side to that. But what happens is the more sides you have, the smaller those exterior angles become, and they always, no matter how many sides you have, always sum up to 360 degrees. And if you need some more images on that, you could do an image search on Google and get some really good visuals on that. We've already done that in the last video. So we know for the first part, the sum of the exterior angles is always going to be 360 degrees. If I want one exterior, I would take that 360 and divide it by 32 sides, 32 exterior angles. So we'll take 360, divide it by 32, and each one exterior angle is going to be 11 and 25/100 degrees. All right, number 7, let's read what this says. So we have A, B, C, D, E. So A, B, C, D, E right here. We have a pentagon. And H, I, J, K, L, those pentagons are regular. So we know that all 5 sides here are the same. And all 5 sides here are the same. And also that what makes it equilateral and equiangular. So I'm going to mark also that these angles are all the same. And we can actually find those because we know how to do that. We just spent some time doing that. And let's actually read the rest of the problem and then we'll come back. AEF GHL is a regular hexagon. So I'm going to switch colors to pink. So I know also that this hexagon is also regular, and I'm going to do 2 marks on it because we have a different shape, and then because it's regular, we also know that all 6 of these angles are the same, which we can find because we know how to do that. If the measure of angle ABK, which is this angle right here, ABK, this angle right here, and LKB, this angle right here, if they are congruent, they want us to find the measure of ABK. So ABK right here. So let's kind of work with what we know. And I'm going to switch back to a little bit of a darker color. So let's first find the angles in the pentagon. So a pentagon has 5 sides. We're going to take off 2, multiply that by 180, and then we'll divide that by 5 angles. So 5 sides, remember we take off 2 because that's how many triangles are in it. So that's going to give me 3 times 180, making a pentagon have 540 degrees in it. If we divide that by 5 angles, that's going to make each one of those angles equal to 108 degrees, 108. So I did a lot of marking on here, so I'm going to kind of clean up and we can come back and remark. But each angle in the pentagon is 108. So we know this is 108, we know this is 108, we know this is 108, 108, and 108. Also on this other pentagon, 108, 108, 108, 108, and 108. Now we also can find the angles in the hexagon. So a hexagon has 6 sides, so we'll do 6 minus 2 times 180, and then divide by 6 angles, making all angles the same. So 6 minus 2 is 4. We'll do 4 times 180, which is 720. We'll divide that 6 ways to get that each one of those angles is 120 degrees. So we have 120, 120, 120, 120, 120, and 120. So, really using a lot of what we've already learned. What we have left up at the top is a quadrilateral, and we know that this side and this side here is congruent on this quadrilateral, which is why these angles here end up being congruent. And that's what we're finding the measure of, is one of those angles. So one thing that we're going to have to think about, and this is something that I hope that you all have already learned in a previous geometry class, right here we have full circle here basically, and full circle is 360 degrees. So I'm going to take 360. Give me a second, my pen is not working. Okay, so let's try again. 360, and I'm going to subtract 108, and I'm going to subtract 120. And you're welcome to use a calculator. So 360 subtract 108 and 120, and that's going to give me that this angle is 132. Well, I have the same thing over here. This is full circle around here. So this is going to be 132. And there's kind of just lots of different pieces to the puzzle here, but I love a problem like this. So we just took 360, subtracted 108 and 120, and got 132. Now what we have to think about is that this quadrilateral adds up to 360 degrees. And I know 2 of those angles, and I know both of those are 132. So Besides knowing, that a circle is 360, a quadrilateral also adds up to 360. So what I'm going to do is I'm going to take 360 and I'm going to subtract the two 132 degree angles that I have. So we'll do 360, take away 132, take away 132, and what that tells me is when I'm left here, I'm left with 96 degrees. That would have to be split evenly among these two angles that are remaining. So I'm going to divide that by 2 to tell me each one of those angles are 48 degrees. So I have 48 degrees here and 48 degrees here. And there's a lot going on in this problem, but this is a really good problem to work. The angle that the question asked me to find was ABK, which I just found. So that's going to be my answer. The measure of angle ABK is equal to 48 degrees. And that's all we're going to do in this video. In the next video, we'll talk about transversals and work with some different kinds of angles that are created when we have two lines crossed by a transversal.